has to run uphill to get to the apex. So are you saying that the Nile is 572 miles deep, Momo? Is that what I'm missing? Because otherwise it would have to be running around the circumference of the earth. Up this arc is uphill, Momo. Are you feeling me now, Momo? Maybe I'm missing something. I need your genius to explain it to me, okay? Because I'm missing, even if this was Mount Kilimanjaro here, that's only 16,001 feet, Momo, okay? Just over 3 miles. So if the river emanated at the peak of Mount Kilimanjaro and ran 3 miles down, how does it get enough force to run 572 miles up the curve of the earth, Momo? I'm confused. So is what you're saying, Momo, is the Nile actually flows south from the apex and north? That the Nile actually emanates from the apex and then flows downhill on each side? That doesn't make much sense to me, Momo. Could you please help me out? I'm confused. Because it sure's starting to look to me like you're full of shit.
If we were rotating and orbiting, as they say, then what you would see is all of those stars would be all going in a sine wave fashion, and not in a circular fashion, but in a sine wave fashion. Why? Because the rotation would give that sine wave its wave amplitude, because it's going around in circles. So you're rotating on the Earth and you'll see this bullseye. But when you factor in the orbit, 67,000 miles of velocity per hour, well then that sine wave or that circle has to go linear, doesn't it? It must go linear because you are orbiting around the sun. So where is that wave that those people taking those time-lapse pictures should be getting only a sine wave. They should not be getting circles. And then of course they point to the fact that the southern stars do the same thing. Yes, they do. And again, proving that we are standing on.
If a telescope is pointing at a star and both are stationary, then obviously the light comes straight into the telescope. In 1729, Bradley found that he had to tip his telescope forward very slightly to get a star in the center of his telescope. It was assumed that this was due to the motion of the Earth around the Sun. Let us assume that the telescope was moving at 5 miles an hour and had to be tipped 5 degrees. This 5-degree tipping, however, could equally be caused by the ether moving at 5 miles an hour, carrying the stars around the Earth. As we see here, the light would be coming in at the same angle and the telescope would still have to be tipped 5 degrees. So tipping the telescope does not tell us whether it is the starlight moving or the telescope moving. However, there is a simple experiment that can determine whether it was the Earth that was moving or the ether and starlight. All that you had to do was record the tipping required for any particular star, then fill the telescope with water, which greatly slows down the speed of light in the telescope. So here is the moving telescope filled with water, tipped at 5 degrees, and you can see that the starlight does not now reach the eyepiece at the bottom. This is because the starlight moves much more slowly when passing through water. However,
And when this happens, you get fall, winter, spring, and summer. The 4 seasons. This symbol is an ancient symbol. You might